Uranus, a beautiful blue-green world, is a planet of mystery. It is an ice giant, far away and very different from Earth. One of the most fascinating things about Uranus is its extreme tilt. Imagine a planet tipped over on its side, rolling like a ball around the sun. That's Uranus. Its unique tilt makes it a captivating subject of study for astronomers. Uranus challenges our understanding of how planets form and evolve. This essay will delve into the secrets of Uranus, exploring its discovery, its tilted axis, and the theories behind this unusual phenomenon. Join us as we journey to this distant world and unravel the mysteries it holds. From its icy composition to its peculiar magnetic field, Uranus is unlike any other planet in our solar system. We will also look at the history of its discovery, the missions that have studied it, and what future explorations might reveal. The more we learn about Uranus, the more we realize how much there is still to discover. So, buckle up and get ready for an exciting adventure into the unknown realms of this enigmatic ice giant. Uranus was not known to ancient astronomers. It is too faint to see with the naked eye. William Herschel discovered Uranus in 1781 using a telescope. At first he thought it was a comet. Careful observations revealed it was a planet, orbiting the sun beyond Saturn. This discovery doubled the size of the known solar system. Uranus is about 4 times wider than Earth. It is made mostly of ices, water ice, ammonia ice, and methane ice. The methane gives Uranus its blue-green color. This gas absorbs red light from the sun and reflects blue and green light back into space. Uranus has the most tilted axis of any planet in our solar system. It's tilted at an angle of about 98 degrees. This means that Uranus rotates on its side. The Earth's axis is tilted at 23.5 degrees, which gives us our seasons. Uranus's tilt is so extreme that its poles point almost directly at the sun for part of its orbit. Each pole experiences decades of continuous sunlight followed by decades of darkness. This strange orientation has a dramatic effect on the planet's seasons. They are extreme and unlike any other in the solar system. The cosmic collision. Scientists believe that Uranus's extreme tilt was caused by a giant collision early in the solar system's history. This theory has been a topic of intense research and debate among astronomers for decades. Imagine a young Uranus, newly formed, being struck by an object about the size of Earth. This colossal impact would have had dramatic consequences for the planet's orientation and structure. This catastrophic event would have been powerful enough to knock Uranus onto its side, altering its axis and rotation forever. The impact would have also released huge amounts of energy, heating Uranus up and contributing to the formation of its rings and moons. The energy from the collision could have caused significant changes in the planet's atmosphere and internal structure. While this theory is widely accepted, there is still some debate about the details of the impact. Some researchers argue about the angle and speed of the collision, which could have led to different outcomes. Some scientists believe that multiple impacts may have been involved. These additional collisions could have further influenced Uranus's unique tilt and other characteristics we observe today. More than just a tilt. Uranus's tilt isn't the only thing that makes it unique. This planet, often overlooked in the solar system, has many fascinating features that set it apart. It also has a system of faint rings, 13 known moons, and a host of other intriguing characteristics. One of these is its very faint magnetic field, which is quite different from those of other planets. The rings of Uranus are made up of dark, icy particles, which are difficult to see without powerful telescopes. They are much smaller and fainter than Saturn's rings, making them a unique feature of this distant planet. Uranus's moons are all named after characters from Shakespeare's plays and Alexander Pope's poems, adding a touch of literary charm to the celestial bodies. Some of the moons, like Miranda, have incredibly diverse and geologically active surfaces, with features that suggest a history of intense geological activity. These features hint at a turbulent past, possibly involving collisions or other dramatic events. The study of these rings and moons is crucial for understanding the formation and evolution of giant planets, providing insights into the dynamic processes that shape our solar system. Unlocking the mysteries of Uranus. Uranus is a fascinating and enigmatic world. Its extreme tilt, unique atmospheric conditions, and system of rings and moons offer valuable insights into the formation and evolution of planetary systems. By studying Uranus, we can gain a better understanding of the diversity of planets in our universe. Future missions to Uranus will allow us to study its atmosphere, magnetic field, and internal structure in greater detail. These missions will undoubtedly reveal even more surprises, and deepen our understanding of this icy giant and its place in the grand tapestry of the cosmos.